In this video we shall discuss multiple and compound conditions usage. For convenience, both tasks are placed here on the same screen. In the first one, we have to show all authors whose books belong to two or more genres simultaneously. And in the second task, we have to show all authors who ever worked in two or more genres. Both results are the same here, but that's just a coincidence on the dataset we have in our database now. Nevertheless, in a couple of minutes you shall see how different the solutions for those tasks are. Let's start with the first task, and for MySQL the solution is the next. We are selecting the ID and the name of an author and the maximum of genres his books belong to. All this information comes from an inner query. Here we also select the ID, the name, and then we have to count genres. All that information comes from three tables. In authors table we have the ID and the name of an author, then we have to make a connection between author and a book and between book and a genre. And then we are grouping our results by author ID and book ID. In other words, we are counting genres for each book of each author. Then we apply this condition that comes from the task. And on the upper level we have to group our data by author ID to select that maximum value. This is how it looks in details. On the first step, the inner query produces the following result. Here we may see authors, and even authors with several books, and genre counts for each book of each author. Then this condition eliminates such lines that do not match that condition. And then grouping on this level allows max function to select maximum value for each author. In our case, we see that these two authors have the same values, here, here, here and here. But let's imagine if, for instance, here the value is 3, not 2, so the result will also be 3 for this author. And we can even go deeper. We can rewrite this inner query the following way. Here we've added book ID and book name into final selection, and now you see that for each author there is a book ID, book name, and genres count for each book of that author. And then we are stepping back to that ID as we've already discussed. We are applying that condition, and then we are selecting maximum genres count for each author using that grouping by author ID. And with Microsoft SQL Server the idea is the same. Here we are selecting the ID and the name of an author, the maximum value for genres count for each author, and all that information comes from that inner query. In that inner query first we have to count how many genres has each book written by each author. Then we have to apply the condition, and then we have to pass that information to the outer level of the query. And with Oracle the idea is the same. The inner query produces information about how many genres has each book written by each author. Then the condition is applied, and then that information is passed to outer level of the query to produce the final result. And now let's discuss the second task. Here we have to show all authors who ever worked in two or more genres. For MySQL the solution is the next. In the inner query we are joining these two tables that store information about connections between books and genres and books and authors. And we are selecting pairs of author ID and corresponding genre ID. Because each author may write several books in the same genre, we have to use distinct keyword here to eliminate duplications. Then we only have to select the information about the author and the count of genres for each author. And in order for this count function to work, we have to group our data by author ID, and then we have to apply this condition that comes from the task itself. This is how it looks in detail with graphical explanation. Let's take this inner query and rewrite it the following way. You see that we've added author name and genre name for convenience here. So these two columns were in the original query and these two columns were added now. And here you see those pairs, author ID, genre ID, author ID, genre ID. Here they are in the initial query. And now the count function counts how many genres are there for each author ID. The only thing left is to apply this condition to eliminate these lines. And that's how we get our final result. For Microsoft SQL Server the approach is the same. We still need those pairs. We need them without duplications, and then for each author ID we have to count the corresponding number of genre ID. And then we have to apply this condition to make our result matching the initial task. Also pay attention that Microsoft SQL Server requires each field presented in select section to be either aggregation function or to be mentioned in group by section. So here it is as long as here it is. And of course for Oracle the idea is the same. Here are our pairs of authors ID and genres ID, and then for each author we are counting the corresponding number of genres ID. And then we are applying this condition to match our result, the initial task.